Welcome to Study Loop.
Welcome back. We're working on chapter 13 and we're on problem 22. Calcium bromide is relatively soluble in water, yet its enthalpy of solution is positive 19.8 kilojoules per mole. It's a big point for us, that positive right there. Which of the following statements provides the best explanation for this behavior? So before we dig in there, let's do a quick reminder. We're talking about enthalpy. And enthalpy is the heat as energy in a system. So let's do a recap over what we know about enthalpy. Enthalpy is heat as energy. So if we call this our system here, and we put heat into this, heat as energy in, that energy going in is going to change our enthalpy. Do you think it's going to go up or down? If you said up, you'd be absolutely correct. Our enthalpy is going to increase because we're going to be having bonds breaking. As a rule. There's a few exceptions to the rule, but we're not going to talk about the exceptions. We're going to talk about the general rule. All right, so if we have heat going out of a system, so heat as energy leaving a system, what's going to happen to that delta H, that change in enthalpy? So going to go up or down. Well, if it went up here, absolutely has to go down here. And that's where we have bonds making. Bonds being made. So now that we've done a recap over this, let's look at what we have here. So we're looking for which of the following statements provides the best explanation for this behavior. Enthalpy of a solution that ends up being positive. So if we have something that's exothermic, heat going out, that's normally a negative, and heat going into a solution is going to be endothermic, and this will be exothermic. So let's see what we have here. Which of these explanation talks about potassium bromide being relatively soluble in water? Potassium salts are always soluble in water. That's absolutely correct statement. That statement is true for us because it is in group 1, our alkaline metals. However, it says nothing about the enthalpy. So even though it's a true statement, it is not explaining what's going on with enthalpy in this situation. So let's look at B. The entropy of the mixing must be unfavorable. Entropy and enthalpy are not the same. So this again is not talking about our enthalpy of the situation, of the solution. So let's look at the third one. The enthalpy, perfect, we're talking about enthalpy, of mixing must be small compared to the enthalpies for breaking up water interactions, and the potassium bromide ionic interactions. So that's absolutely correct. So what we're looking at here is the enthalpies of water breaking up, water to water, and the KBR. So we're breaking bonds, so that ends up being positive, and this is positive. So C is correct. That's absolutely our answer. It explains everything perfectly about enthalpy of a solution that ends up being positive. All right, let's look at this last one. Potassium bromide has a high molar mass compared to other salts like sodium chloride. Does molar mass have anything to do with enthalpy? No. The only thing it has to do with enthalpy is bonds being made or broken. So watch out for answers that are completely true, that aren't answering the questions that you're looking for. If you watch out for that, you're going to do great on your test.